Okay, good morning. Today we're going to start talking about section 10.2, mass and the mole. And in this section, the first part of this section, we're going to kind of break this up into two different chunks, okay? So the first part that we're going to do today, we're going to focus on the mass of a mole of whatever. Whether that's a mass of a mole of an element such as carbon or chlorine or hydrogen or whatever, and or it could be the mass of a mole of sodium chloride or the mass of a mole of methane, CH4, or whatever that might be, okay? And then we're also going to learn how to calculate that. And excuse me, and then we're also going to look at how to use those molar masses that we calculate in calculations. So when we obtain or when we calculate the molar mass, then what do we do with it next? Why did we do that? What was our purpose? And what can we do with that newfound information? But first, let's revisit something that we discussed in section 10.1. I need to clarify something to make sure that we're all on the same page. And then I also want to do one of the homework problems on section 10.1 as I was looking through your homework problems that I was seeing, some of the mistakes that you all were making, okay? So let's start with that. Okay, so we're going to revisit 10.1. All right, so if I told you I have one molecule of water, H2O, okay, one molecule of water, you know that means I have two hydrogen atoms and one oxygen atom. Okay. Now, keeping that in mind, if I told you I have one mole, let me move this up a little bit actually, 1 mole of H2O molecules so I have 1 mole of them, okay? That means I have 2 moles of hydrogen atoms and 1 mole of oxygen atoms, okay? Now, let's go back to this first side here. How many total atoms do I have in 1 molecule? I have 3 total atoms. That doesn't look like a 3. I'm going to fix that. Okay. Okay, so I have 3 total atoms in 1 H2O molecule, right? Yeah, of course. Now, I have 3 moles, total moles we'll say, okay? 3 total moles of atoms in 1 mole of H2O molecules. Okay. I hope that makes sense. That looks like an arrow. I'm going to fix it. Okay. Okay. So I hope that makes sense, because some of you, or there were a couple people that had emailed me and said, I don't understand how we can have 1 mole and then we end up with 3 moles of the atoms. That is, just think of it as when we have 1 molecule, there's 3 atoms that make up that molecule. When we have 1 mole of molecules, that still means we have those 2 moles of the hydrogen atoms and we have 1 mole of oxygen atoms, okay? Also, I want to keep in mind, I want you to keep in mind, a mole is just what word do I want you to remember? Quantity, right? Nothing more, nothing less. What other quantities can you think of? Let's throw some out. Okay, dozen. Okay, that's 12. If you have a ream of paper, has everyone heard of a ream of paper? Ream of paper is 500 sheets, okay? If I have a gross, that's 144, okay? Baker's dozen. Baker's dozen, that's 13, okay? So it's just a quantity, nothing more, nothing less. Don't try to make it into, something that's more complicated, okay? All right, now let's look at that problem that I kept, excuse me, I kept looking at, and I wasn't quite sure how some of you got the answer that you got. So I'm on page 323, and it is number 2. Okay, so on page 323, number 2, it says calculate the number of molecules in 11.5 moles of water. Okay, so if I'm going to calculate, I better find my calculator. I'm going to give you guys a second to grab yours. You're going to need your calculator every single time we sit down to do chemistry together, whether that's at home, in my home, in your home, or if that's in the classroom, hopefully sometime very soon, wherever that might be. Always make sure you have your calculator handy, please and thank you. Okay, so number 2, we're going to start with what we're given in the problem. 11.5 moles of H2O. All right, now when we're doing this, so we're going from moles to molecules, okay? When we're doing this, of course, we know we need a conversion factor, and that conversion factor must be equal to 1, don't forget, okay? So what do I put on the bottom? Well, I've got moles here on the top, so in order to get that to go away, I want moles on the bottom, okay? So in 1 mole, I'm going 2 molecules, right? I have 6.02 times 10 to the 23rd molecules. Now, remember that to from thing that I told you, right? The unit you're going to goes on top. The unit you're going from goes on the bottom. Why does it go on the bottom? Because I want that to cancel, right? That is going to cancel, and then I'm going to be left with my molecules. Well, that's what I want. Fabulous. So, all right. Now, Let's pick up the calculator and we do 11.5 times 6.02 times 10 to the 23rd, and I get 6.923 times 10 to the 24th. Well, wait a minute. How many sig figs do I want? I only want 3, right? So my answer should only have 3 as well. So this answer is 6.92 times 10 to the 24th. Don't forget your unit. That's super important, okay? And then we're going to put a pretty little box around that, and we're going to call it done, okay? So now, just to kind of recap what we did here, okay? So we had 11.5 moles. That's what we started with, okay? So we start with what we're given. We're going to change it to molecules. My moles need to cancel, so that needs to go on the bottom. My molecules goes on top. I pick up the calculator. 11.5 times 6.02 equals 6.02 times 10 to the 23rd. Don't forget that 23rd, of course, okay? Equals 6.923 times 10 to the 24th. I only want 3 sig figs, so I shorten that to 6.92 times 10 to the 24th molecules. All right? Okay, moving on. Now let's get into 10.2, okay? Molar mass. Molar mass is, excuse me, is the mass, this is going to sound really simple, or really silly actually, because it's so simple. The mass of a mole, okay, we use the unit grams per mole, okay? That makes sense, right? So molar mass, the unit, is grams per mole. Okay. Units grams per mole, and it's equal to the mass of a mole. Okay. All right. Now, in chemistry, we know of 2 masses. That are found on the periodic table. Let's look at carbon, for example. If you look at the periodic table for carbon, the mass that is listed on the periodic table that I have in front of me is 12 carbon, for example. Well, I didn't write on the line, but oh well. 12.011. And if we're talking about an atom, what unit do we use for an atom? So 12.011 is the mass that's listed on the periodic table. If we're talking about an atom, we use the unit AMU. AMU stands for atomic mass unit, right? So that's why it's AMU. Makes sense. Okay, if we're talking about a mole, it's that same number. This is the mass of a mole, okay? And so we use grams. Okay, so this is just the mass of a mole. Okay, so we use grams. When you are writing molar mass, though, I want to make sure that you understand why I'm just saying here the unit is just grams, because this is the mass of a mole. But if I'm talking about specifically, if I'm describing molar mass to you, I'm going to say the molar mass of carbon is 12.011 grams per mole, okay? or I could say it like the mass of 1 mole of carbon is 12.011 grams. Okay, but I'm saying the same thing. Okay, everybody with me? Yes, I hope. Okay. Now, so just looking at, the mass of the molar mass of anything on the periodic table. So if you'll get your periodic table for me, I'll wait for you. So the molar mass of chlorine is 35.45 grams per mole. Okay. The molar mass of nitrogen is 14.01 grams per mole. Okay. The molar mass of hydrogen is 1.01 grams per mole. All right, now we're going to take it just a little bit further. Whoops. Let me get back to a writing utensil. There we go. So the molar mass of sodium chloride, NaCl. How do you think we do that? Well, we're going to find the molar mass. We have 1 sodium, right? With 1 sodium, and that has a molar mass of 22.99 grams per mole, right? Right. Then we have 1 mole of chlorine, and that molar mass is 35.45. Where'd my point go? There we go. Grams per mole. So the molar mass of sodium chloride is 58.44 grams per mole. If you remember yesterday, Tuesday rather, when we did the notes for section 10.1, there was that little blue dish on the balance, and I said that's 1 mole of sodium chloride, and that balance showed a mass of 58.44 grams, right? So that was the molar mass that was the mass of 1 mole of sodium chloride. So the molar mass of sodium chloride is 58.44 grams per mole. Got it? Perfect. All right, now let's do one more, and then we're going to move on. The molar mass of methane. Which is CH4. Have you ever written with one of those pens, like at the doctor's offices, or like if you have to sign something when you go to pick up a prescription or something? It's those. That's what I feel like when I'm writing on this iPad with this. Like, I don't think I have terrible handwriting normally in real life, but with these, I don't know. There's no neat handwriting for me. I don't know. But anyway, so I'm glad you're understanding about that. So the molar mass of methane. In 1 mole of methane, I have 1 mole of carbon atoms, right? And my carbon has a mass of 12.01 grams per mole. Well, my hydrogen, I have 4 of them, okay? And my hydrogen has a mass of 1.01 grams per mole, but I'm going to multiply that by 4, okay? Because I have 4 moles of hydrogen atoms in every 1 mole of methane. So I'm going to multiply that 1.01 by 4, and of course I end up with 4.04 grams per mole. Now, when I add these up, I am going to take my, 12.01, and I'm going to take this one, okay? So I'm going to end up with 12.01 and 4.04, and of course that's 16. So the molar mass of methane is 16.05 grams per mole. Okay. All right. Excuse me. So the molar mass of methane is 16.05, and I just added those two parts up like that. All right, everybody good? Perfect. No matter how complex the compound is, we would do that same thing. So it doesn't make it any more difficult just because there's more elements to it. I have one more thing that I want to show you before I end this video, and that is, what are we going to do with this? Okay, so we're going to learn how to do mole to mass conversions. Mole to mass conversions. So let's say I have a container and it says I have 4.61 moles of aluminum. And I want to know what the mass is. But I don't have a balance handy, okay? I don't have a balance, or maybe I have a balance, but it's broken, or whatever, okay? But I know this container has 4.61 moles of aluminum in it. So I'm going to start with what I'm given in the problem, 4.61 moles of aluminum. And in here, I'm going to put the molar mass of aluminum. Okay. What I mean by that is if I have 1 mole of aluminum, what's the key part about that has to happen in this conversion factor? It must be equal to what? Must be equal to 1, right? Well, the same thing holds true here. If I have 1 mole of aluminum, how many grams do I need to have? Well, as per the periodic table, I need to have 26.98 grams of aluminum. Is this fraction here equal to 1? Well, look at it. If I have 1 mole of aluminum and I have 26.98 grams of aluminum, do I have the same thing? Does that in fact equal 1? Sure, of course it does. It equals 1, right? So does this change this value? No, it only gets rid of my moles, right? And then I'm left with grams of aluminum. So now let's do the math. So I pick up the calculator and I do 4.61 times 26.98. And how many sig figs do I want? Well, I want 3 because that's what I started with in the very beginning of the problem. So I'm going to end up with 120. The calculator says 124.3778. Okay, I only want 3 sig figs. So that's 124 grams of aluminum. Okay, and that is a mole to mass conversion. All right, let's do one more. If you get it, great. You can just kind of follow along with us here for just a second, okay? Excuse me, because we're going to do a mass to mole conversion. So this is just the opposite of what we just did, okay? So let's say, excuse me, let's say we have 25.5 grams of silver. And I want to know how many moles this is. Okay, so we're going to start with what we're given in the problem, 25.5 grams of silver. Again, this must equal 1, right? It must equal 1. If it doesn't, I'm changing the value of this number, and I don't want to do that, okay? So this must equal 1. Absolutely must. Okay, so what do I want to put in the bottom? Well, I want my grams of silver to go away, and I want to go 2 moles. So in 1 mole of silver, look at your periodic table and tell me how many grams there are. So I end up with the periodic table tells me 107.87 grams of silver. So I pick up the calculator and I do 25.5 divided by 107.87, and I end up with, the calculator tells me it's 0.236395, blah, blah, blah. A few more numbers, okay? I only want 3 sig figs because that's what they gave me in the problem. So I'm going to put, my answer here is 0.236. My grams cancel, and I'm left with moles of silver. Sorry, that wouldn't write for a second. Okay, 0.236 moles of silver. Everybody good? Perfect. All right, that was a little bit longer than I anticipated. Thanks so much for sticking with me. Hopefully you did. I will post your homework to Google Classroom, and we will be taking this a little bit further tomorrow on Friday when we do the rest of the section 10.2. Okay, and also hopefully you haven't already turned this off, but I'm also going to host a Google Meet on Friday, probably somewhere along 11 a.m. I'm not sure how many people will be interested. So if I get, have too many, then we might have to split it up into different sections. Okay, so we might have to do 2 different times or 3 different times or whatever. So we'll see. Okay, have a great day. Thanks so much. Reach out if you need anything. You know how to get me. Thanks a lot. Bye-bye.